Welcome to the chapter 6. This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to define sets, represent sets, explain different types of sets, draw Venn diagrams, explain the operations of sets. Introduction. Before you enter into the lesson, follow the instructions shown on the screen. We know that when things are grouped based on a criteria, they form a set. The images shown on screen, taken from our daily life from several sets. Now, consider the number of subjects taught in class 10th under CBSE and SSC patterns of education. Under CBSE pattern of education, the 5 subjects form a set. Similarly, the number of subjects in class 10th under SSC pattern of education is 6 and can form another set. Some of these subjects are common in both the systems of education, like mathematics, science, social studies, and English. The subjects like Hindi or Sanskrit are specific to CBSE system of education only. In the same way, the subjects Telugu or Hindi are taught only under SSC system. Do you know? In this chapter, you will learn in detail about learn more about the concept, properties, types, and operations of sets. We know that when things are grouped based on a criteria, they form a set. We come across some sets of collections in mathematics also, like natural numbers, prime numbers, quadrilaterals in a plane, etc. A well-defined collection of objects or ideas is known as set. A theory of set was developed by German mathematician Georg Cantor. Let us know about well-defined sets. Well-defined means that all the objects in the set should have a common feature or property. For example, in the image shown on screen, all the objects are painting brushes, but sizes are different. It should also be possible to decide whether any given object belongs to the set or not. For example, if you consider a toothbrush, it doesn't belong to the set because both the objects toothbrush and painting brushes have different properties. That is, one is for painting and the other is for brushing the teeth. The 3 examples of sets from our daily life are set of jewelry, collection of Indian coins and geometrical tools as shown on screen. Some collections are given below. Take which of the following collections or sets. Naming of sets and elements of a set. Let us see graphically how sets are noted down. Let us consider a set denoted by B. In this set, we have numbers from 1 to 9. These individual numbers in the set are known as elements. So 1, 2, 3, 4, 5, 6, 7, 8 and 9 are the elements of set B. Sets are denoted using curly brackets as shown on the screen. Sets are usually designated with capital letters A, B, C, X, Y, Z, etc. The notation to show an element belongs to a set B is the belongs to symbol as shown on screen. Similarly, the notation to show an element does not belong to a set B is does not belong to symbol as shown on screen. The examples of both the notations are shown on the screen. Finally, elements of a set are usually designated with lowercase letters. For example, A is equal to set containing the elements A, B, C and D. The set of all natural numbers is denoted by N. The set of all integers is denoted by Z. The set of all rational numbers is denoted by Q. The set of all real numbers is denoted by R. Note that all the sets given above are well-defined collection of sets since the given numbers are decided based on whether they belongs to the set or not. Similarly, if we define a set of all days in a week, and if we consider the weekdays start with the letter T, then Tuesday and Thursday are a part of set, but the remaining days are not. So, here in this case, we say that Tuesday and Thursday are the elements of the given set. We come across some sets of collections in mathematics also, like natural numbers, quadrilaterals in a plane, etc. Representation of sets. The two ways of representing sets are roster form, set builder form. Click each tab to know more. Representation of sets on roster form. In this form of representation, elements of the set are listed within the pair of braces and are separated by commas. The other example is set of all letters in the word mathematics. Its roster form is written as Z equal to set of letters M, A, T, H, E, I, C, S. Example: the set of all vowel letters in English alphabets. Its roster form is written as Z equal to set of letters A, E, I, O, U. Note that the order in which the elements are listed is irrelevant, but elements must not be repeated. The other method of representing the sets is set builder form. In this form of representation, a set is well defined by a statement and it is written within a pair of braces. The symbol X is used to denote the elements of the set. However, any other variable followed by a colon can also be used as a notation of the elements. The symbol on screen is used to denote such that using this notation we write the property possessed by the elements of the set and enclose the whole description in braces. Here, the braces stand for set of all and mean all the elements in the set. Example: the set of all vowel letters in English alphabets. Its solution is as shown on screen. The table shown on screen contains 3 examples of sets, each represented with a word description, roster form and set builder form. Example 1. Write the following in roster and set builder forms. The set of all natural numbers which divide 42. The set of natural numbers which are less than 10. Solution. The natural numbers which divide 42 are as shown. Let us assume A be the set of natural numbers which divide 42. Therefore, in roster form, we can write as shown. And also in set builder, we can write as shown. The natural numbers which are less than 10 are as shown. Here, assume B be the set of all natural numbers which are less than 10. Therefore, in roster form, we can write as shown. And also in set builder form, we can write as shown on screen. Example 2. Write the set B shown on screen in the roster form. Solution. Given B is shown. The square of natural numbers which are less than 40 are as shown. And 7 square is equal to 49, which is greater than 40. So, the natural numbers are as shown. Therefore, in roster form, we can write as shown on screen. List the elements of the following sets. Solution. Factors of 20 are as shown. We can write the elements of the set as shown on screen. The multiples of 4 between 17 and 61 are as shown, but the numbers which are divisible by 7 are 28 and 56. We can write the elements of the set as shown on screen. M, A, D are the letters from the word madam. We can write the elements of the set as shown on screen. The whole numbers between 3.5 to 6.7 are 4, 5, 6. We can write the elements of the set as shown on screen. Write the following sets in the roster form. Solution. Months having 30 days in a year are April, June, September, November. In roster form, we can write B as shown. Prime numbers less than 10 are 2, 3, 5, 7. In roster form, we can write B as shown. Colors of the rainbow are violet, indigo, blue, green, yellow, orange, red. In roster form, we can write X as shown. Match roster form with the set builder form.
Let us solve a few exercise problems. Click the tab to view solution.
Types of sets. The sets are classified into empty set, finite set, infinite set. A set does not contain any element is known as empty set. It is also known as null set or void set. Empty set is denoted by the symbol shown on screen. Example. The set of natural numbers smaller than 1. Here, the above example is empty set because in the example, as there is no natural number smaller than 1, it is an empty set. Note that empty set and set with element 0 are different sets, because set with 0 element is a set containing the single element 0, while empty set is a null set. Some of the examples of empty set are shown on screen. Now, let us discuss about finite set. A set is finite if it consists of a countable number of elements. Here, the process of counting the elements comes to an end. For example, students in your school. Number of elements in set L shown on screen. Set of people living in a town, etc. All the above examples are countable. In first example, you can easily say total strength of your class is 10. And in the second example, we can see that number of elements in L are 4. Similarly, we can also count number of people living in a town. Infinite set. A set with infinite number of elements is called an infinite set. Example, list of all even numbers, number of straight lines passing through a point, collection of integers, stars in the sky. Let us solve a sample problem on these forms of sets.